let us see what I meant by pointers being a replacement for arrays. So, let us look at the small piece of code here. So, we have int my array equals this. Okay. So, let us think about what it really is doing. So, int my array, there is a left and right square bracket equals a list of values, right. So, what this does is it takes the set of values on the right side. So, we have 1, 23, 17, 4, minus 5 and 100, there are 6 values. So, int my array is actually an array which can take 6 values. So, the size of my array is 6 values. Then we have star ptr and I, right. So, instead of explicitly saying my array should be an array of size 6, we let the compiler figure out how many values are there on the right side, based on that appropriately take the size of size for my array. So, in this case the size of my array is 6. So, following that we have star ptr and I. So, what we have in this line is we have 2 integers, one integer called I, one integer array called my array and one integer pointer called ptr. So, that is what you have in line 1. And in the next line we have ptr equals ampersand of my array of 0. So, ptr is now pointing at the 0th location of my array. You can also replace this with ptr equals my array, that is also valid and it does the same thing. So, let us look at this loop here. So, printf my array of %d equals %d. So, it is saying that print my array of some integer equals some integer I comma my array of I. So, I am going to call this line A, and in the next line we have contents in address ptr plus %d equals %d, and for the first %d we give I, and for the second %d we give star of ptr plus I as the variable to be printed. So, let us see what this means. So, in the first line it is straightforward, you are printing the index of the array as well as the value contained in the index for I equals 0 through 5. So, my array has 6 values and it goes from 0 to 5, and this next line contents in address ptr plus. So, if you see the loop, it will take I will take 0, 1, 2, 3 and so on. You will see contents of ptr plus 0, contents of ptr plus 1, contents of ptr plus 2 and so on, all the way up to ptr plus 5. So, that is what you are seeing on this, and star of ptr plus I means take ptr plus I, which means move it by appropriate number of locations from the base and dereference it using the star operator, and I am going to call this line B. So, I will tell you quickly why I want the lines to be named A and B, but let us take this program and run it. So, I have already taken this program and copied it into my editor, and let me compile it and run it. So, let us see what is happening in the output. So, let us take some time to see what is printed in the output. So, the first line is my array of 0 equals 1, contents in address ptr plus 0 equals 1, that is what it says. So, let us see my array in the program. So, my array is 1, 23, 17, 4, minus 5 and 100. So, my array of 0 is indeed 1, and ptr plus 0, which means the contents of ptr plus 0 is star of ptr plus 0. So, ptr plus 0 is ptr itself and star of ptr is pointing to 1. So, it is printing 1. Then my array of 1 is 23 and ptr plus 1 is supposed to point at the location one step away from ptr. So, remember ptr is only pointing at my array of 0. So, one element away from that is a of 1. So, ptr plus 1 is the address of a of 1, and when you do star of ptr plus 1, you are asking for the value contained in 1th location of a, which means you are asking for the value of a of 1, and this goes on. So, ptr plus 5 is asking for the value, so star of ptr plus 5 will get the value which is at a of 5, and it happens to be 100, and that is what you see here, right. So, let us do a small change to the program, and I want to show that my array is something that cannot change. So, let us say I do this my array plus plus, right. So, what I want my array to do is point to 23. So, I want my array of 0 to be 23, my array of 1 to be 17, and so on. Therefore, I am trying to increment my array by 1. So, it will not point to 1 anymore, it is supposed to be pointing at 23. So, let us try and compile this, let us try and compile that, and let us look at this error that happens, right. So, in fact, the compiler stops and points error at line number 13. It says L value is required as increment operand, right. So, it is not a very useful error to see, but many compilers for C actually give you errors that are slightly cryptic. In this case, what it is saying is, so let us change this a little bit. Like I said, this is equivalent to saying my array is my array plus 1, right. So, let us compile this, you still see the same error, right. So, on the right side, so it says error incompatible types when assigning to type int of 6 from type int star. So, on the right side it is doing my array plus 1, which means you are asking for one location away from my array, and on the left side you are assigning it to my array. Even this is it gives a compilation error. So, based on what you write, right, so it is changing the error, but the basic point is it is not letting you change what my array should be pointing to. Whereas, if I had done this, let us say I did PTR, right, equals my array. If I did that, so let us look at line number 13. So, if I compile it, it is technically not a problem, because so PTR, so even in this line PTR equals my array of 0 is actually the equivalent to this line PTR equals my array. So, I said these are lines A and B. Let us see why this is useful. So, I want to use it for to illustrate something now. So, both plus plus PTR and PTR plus plus are actually equivalent to saying PTR plus 1, right. You are incrementing PTR by 1, though at different times. So, there is a difference between saying plus plus PTR and PTR plus plus. Plus plus PTR is called the pre-increment operator. So, it means increment the value of PTR and then use it, and PTR plus plus is post increment operator, use the current value of PTR and then later increment the value of PTR. But I want you to do this little exercise. So, change the line B. So, if you look at line B, it is saying contents in address PTR plus percentage %d is I comma star of PTR plus I. So, change that to star PTR plus plus and run it again, and once more change that line to star plus plus PTR and run it once more. So, you take this piece of program which is in this slide, but make changes to line B using either this line or this line, compile and run it, and try and reason why whatever is happening, why it is happening. So, try and reason about that, right. So, let us move forward. There is another useful thing in C which is called the size of operator. So, it is not directly relevant to pointers, but this is something that I want to talk about now, and I can use the size of operator to explain a few things later. So, in this program we have 3 integers called int size, chr size and float size, FLT size, and we are going to do this. Int size is size of int, chr size is size of char, and FLT size is size of float. So, as the name might indicate to you, right, you are looking at the size of an integer or size of a character and size of a floating point and so on. What does it mean by asking for size of an integer? So, integer is so it is a set of values, right. Integer is actually a set of values, and this can be so if you go and look at the real world, the set of integers is unbounded in size. So you have all the way from minus infinity to plus infinity. It is not something that a C language supports though. So you cannot store every possible integer that is out there. C instead restricts it to be at least 4 bytes in size. So if you say size of int, it is actually giving you the number of bytes that is used to represent an integer. Similarly, size of character will give you the number of bytes required to store a character, and size of float is going to give you number of bytes to give you for storing a floating point number and so on. So these things can vary across different machines and so on, but the basic point is whenever you do size of int, for the machine that you are running on, it will tell you how many bytes are required to store an integer. So in most modern machines, the size of integer is either 4 bytes or it can be even 8 bytes. So let us look at a few things related to pointer arithmetic. So I am going back to pointer arithmetic. You can do a lot of things with pointers and arithmetic related to pointers. So you can assign between pointers of the same type. You can do addition and subtraction between a pointer and an integer. We already saw this example. We did PTR plus 1 and PTR plus plus and so on. So PTR was of type pointer and plus 1 is actually adding an integer 1 to PTR. So however, C allows you to do that. You can compare two pointers that point to elements of the same array. You can even subtract two pointers. We will see a small example at the end of this module, and you can assign and compare. So these are several things that you can do with pointers. Let us see each one one after the other. The first one is increment decrement, right. So if P is a pointer to type T, so in this, so there is actually no data type called T in C. So I am using this as a template. Let us say I have a data type called T and P is a pointer to T. So T could be an integer, character, floating point, could be anything, right. P plus plus will increase the value of P by size of T steps. So I already mentioned this. If you say size of data type, it tells you what is the number of bytes required to store the data type. So when you do P plus plus, it is not incrementing P to point to the next byte, it is going to make P point to the next valid element of the data type T. So let us say my integer is actually 4 bytes, right. So I have an integer called A and let us say it is occupying 4 bytes. This is not an array of size 5. So I am drawing a memory footprint, and let us say variable A is stored in 4 bytes. Let us say location 100, 101, 102, 100 and 103, and let us say location 104, 5, 6 and 7 are the next set of locations. If PTR is made to point to A, and if you do PTR plus plus, PTR will not point to 101 because the data type PTR is pointing to is integer. The next valid integer is 4 steps away from 100. So PTR plus plus will make it point to the integer at location 104. So let us go back to the slide. So we have, if we have data type T tab of n, and if we have a declaration T star P, so you can substitute T with int, char, float, whatever you want, right. So T itself is not a valid data type, and let us say int I equals 4. If I do P equals ampersand of tab of I, right, so I is 4, so ampersand of tab of 4 will make me point to the 4th entry in tab. So remember, the entry start at 0, so we are talking about 0th, 1st, 2th, 3rd and 4th. So the ith entry is the 4th entry starting from 0. So P is going to point at the 4th entry in tab, and when you do P plus plus, it actually starts pointing at the next entry in tab. So this is an example of pointer arithmetic where you mix pointer and integer operations on it. You can also do add and subtract from pointers. You do not have to do just increment and decrement, you can also add. So, in this example what we have done is we have made P point at the 0th location of tab and we are adding 5 to it, which means it will start pointing to tab of 5. It will start pointing to tab of 5. You can compare pointers. If P and Q are pointers of the same, if they are pointing to members of the same array, then you can do things like equal to, not equal to, less than, and so on. So, let us say I have an integer array, and so in this case I am drawing an array, not memory, I am drawing an array. Let us say I have an array A, and let us say this is A of 0 and this is A of 4. If I make P point at this location and if I make pointer Q point at this location, then I can actually ask a question, is P less than Q? So, the meaning of that is P pointing to a location that is earlier in the array than what Q is pointing to. In this case, P is less than Q is actually true, right. So, you can also do is P not equal to Q. So, in this case P is actually not equal to Q. P is pointing to the 0th location, Q is pointing to A of 4. So, P is actually not equal to Q. So, you can meaningfully compare pointers which are pointing to the same array. You can ask, is this the same, is this earlier than the other pointer, is it later than the other pointer, and so on. So, you can make pointers point at different locations in an array. You can ask questions whether one pointer is lesser than the other and so on, right. And you can also compare it for inequality with 0. So, you can ask a question, is P equal to null. So, let us say P is pointing to A of 0 and I can ask a question, if P equal to null. If I ask this question, this will actually evaluate to false because P is actually pointing to A of 0. So, you can do comparisons of this kind. So, we looked at increment, decrement, and adding an integer or subtracting an integer from a pointer. One final beautiful thing about pointers is that you can also do subtraction of pointers. So, there is a small piece of code here which actually tries to show that. So, this one is slightly loaded, but let us see what it is doing. So, there are two pointers here, one called S and one called P, and this is actually a function which is called string length, strlen. So, given a string, it tries to find out what is the length of the string. So, let's see what a string is in C. I will anyway do this in more detail later, but a string in C is actually just a sequence of characters followed by a special character called \0. So, for instance, let us say I have a string called hello, it will be stored in this form. You have H E L L O, so this is letter O, and on top of that in C there is a special character called \0, so in this case it is actually 0, or what is called the null character. So, a string called hello, it is supposed to be of length 5, but in reality it actually takes 6 bytes, right. So, let us say I want to find out what is the length of this string, right. So, I can keep checking starting from the 0th location of this string. I can keep checking for one character after the other, and I will look for the special character called \0. The moment I see a \0, it means that this is the end of the string, and this is a convention used in C. So, like I said, we will again see this in more detail later, but as of now let us look at this example, right. So, let us say I want to find out what the length of the string is, right. So, I have written a small function which does that. So, character star S and character star P. So, at this point P is initialized to S. So, S is supposed to be a character array, right. So, S is a pointer to a character array, that is what you see here. So, S is pointing to a character array, and character star P equals S. So, P also points at the 0th location of S. So, S is the string for which we want to find out the length, right. So, there is a while loop here that keeps checking if the contents of the memory location pointed by P is it \0 or not. So, there is a special character \0. I am going to start from location h, so where h is stored all the way till I see a \0. So, initially p is pointing at h and star p is not equal to \0, we do a p plus plus. So, p will start pointing here. So, p has already moved by location, moved by one location, right. It has started pointing at s of 1. S of 1 is E and it is not \0. So, the while loop will continue, it will start pointing at L and this will keep happening and it will stop when p points at \0. So, let us assume that this is at location 100, this is at 101 and so on, this will be at location 105. So, when the while loop stops, right, the while loop will stop when star p is equal to 0, right. When is star p equal to 0? When p is 105, star p is \0 and which means when p equals 105 the loop will stop, right. So, at that point if you go and ask for p minus s, right. So, p is 105 and s is memory location 100, 105 minus 100 is 5, that actually gives us the correct length of hello, right. So, this is a very neat and beautiful trick to show with pointer arithmetic. So, let us not worry about what this return statement is and what is this strange looking int strlen and so on is later, but as of now I just want you to pay attention to the while loop. So, it iterated over the elements of s and it stopped at \0. At that point p got value 105 and if you do p minus s, it actually gives you 105 minus 100 which is 5. So, when you do arithmetic over pointers, if you do subtraction of pointers, you actually get an integer back and this is something that is very handy. We will see cases for use cases for this in a lot more detail later. So, we have now come to the end of this module. In the subsequent modules, we will see how to use pointers for manipulating arrays and we will also see how pointers are useful in the context of what are called functions. So, we will start looking at functions and when we visit functions, we will revisit how pointers are handled when we pass them on to functions. Thank you very much.